So remember, we're working on this conjecture that A cross C intersect B cross D equals A intersect B cross C intersect D. And last time we proved part of the proof, but now we need to look at part 2 of our proof, which is showing that A intersect B cross C intersect D is a subset of A cross C intersect B cross D. So just like before, we're going to start with an outline for this proof. What does the outline look like? We're going to start with an element x comma y in A intersect B cross C intersect D. And I need to end up with an element on this right hand side. So in the end, I need to show that xy is in A cross C intersect B cross D. So what does that mean? It means that I need to show that xy is in A cross C and the ordered pair xy is in the set B cross D. So going forward, I know that x is in A intersect B and y is in C intersect D. This means that x is in A and x is in B. This means that y is in C and y is in D. But since x is in A, and y is in C, xy is in A cross C, and since x is in B and y is in D, I know that xy is in B cross D. And so now I have that xy is in A cross C and xy is in B cross D, which is exactly what I needed to get to. So now that I have my outline done, we're going to write the formal proof here. And again, reference your outline when you're doing this. Let xy be in A intersect B cross C intersect D. Then x is in A intersect B and y is in C intersect D. Since x is in A intersect B, x is in A and x is in B. Since y is in C intersect D, y is in C and y is in D. But now I have that x is in A and y is in C. That means xy will be in A cross C. I also have that x is in B and y is in D. That means that xy is in B cross D. And so what do we got? Therefore, xy is in A cross C and xy is in B cross D. And we can conclude that xy is in the intersection of these two because it's in both of them. So we've proved that A intersect B cross C intersect D is a subset of A cross C intersect B cross D. And this completes part 2 of our proof. And so because we've proven part 1 and part 2, We've shown that both sets are subsets of each other, which means that we've established that these two sets are, in fact, equal.